All right. Well, this is the crowd, right? So I don't think we need to wait for anybody else. This is like the normal people that are normally here.
Well, consistent. Not very reliable, but consistent.
Wait a minute. Aren't those the same thing?
Hmm. No, I would say there's some nuanced differences.
Okay.
Yeah.
Consistently unreliable.
Could be. Very.
Oh, I'm
Reliably
consistent
inconsistent.
most times.
Yeah.
All right. So did my bell work or do I have to adjust my sound
Yes.
again?
No, we can hear it.
Yay.
Okay, now stop.
All right. Let me share something. Let me move my junk out of the way.
Display, you look way too comfortable. I cannot allow it.
Display always looks way too comfortable.
Yeah.
I promise you, the chair is less comfortable than it looks. It's hard as a rock.
And you get your drinks like right within arm reach there with your yellow fridge.
True.
Do you have a
Speaking of,
dog? I feel like the Chewy.com box.
no,
He eats dog food.
my parents have a dog, and this is the box I've used as
my
like
God.
my collection for all my bills that I just need to sort. So, had a dog.
Hmm.
Had two actually.
Nice.
Where's my
But,
Zoom screen? Mother of pearl.
That's for later.
Yeah.
All right, I'm sharing my whole screen again. It makes me very uncomfortable to do this. But here we are. All right.
Mm-hmm. Yep.
So what do you see? You see a giant
Yep.
Yep. We see
PCB?
it. Pico with
All right. So somebody, I nominate Kevin.
God.
Now let's nominate Display because he's more
Yes, that's-
consistent than Kevin.
Definitely.
Display,
Okay.
do you still have the original circuit breadboarded from class 2-ish?
I do not, but I can quickly get that set up.
Well, I just need to know what the connections are because to stay on track with the intent of the course to keep a direction going, I want to fulfill that. Does anybody still have it breadboarded as discussed in 2?
I was never actually successful in getting it breadboarded, so
You suck.
I know. Tell me about it.
Well, I
Display
suck too because I moved my whole setup down to the basement to make room on my desk for other things. So
Again, I can get it set up quick enough, I think.
okay.
Well,
Well, if somebody knows what the pinouts are, that would be helpful.
Yeah, I was going to say that the important thing isn't the setup; it's to know the pinout. So if Display, if you can remember, even just starting of it, like which pin the NeoPixels were connected to.
It was pin 16.
16 is the NeoPixels.
Yep.
Oh, yeah.
16 is the data out, and then
So,
I used
yeah.
I think 20. I need to look at the chart again, but
Yeah.
one of the ground pins on the same side, and the 3-volt.
So one thing,
3.3.
one thing we probably want to be careful here is to standardize the nomenclature. When you say 20, is that GPIO? Is that IO or GP20, or is that pin 20?
Pin 20 on the Raspberry Pi, Raspberry Pico.
Yeah, what's it actually labeled? Is it labeled GP20?
I need to look at a chart. Sorry.
Yeah.
Because actual pin 20 is GP15 according to this diagram.
That's where I was getting at. So
GPIO 20 would actually be pin 26. So that's a good point. It's important to be
one of the
crystal clear with this stuff.
Yeah, pick one nomenclature or the other and stick with it for the duration.
Fair enough.
Oh, actually, you could tell by looking at your code.
That's true.
If you look at the code,
where's my Thonny?
It will have
the code
declaration for the NeoPixel, and it will tell you which GP pin or IO pin. I can't remember what nomenclature they use for.
I think it's IO
Pico.
pin, but
that's fine.
Darn, I'm looking for the reference chart for the, maybe it's in the class one.
Just look at your .py file.
The
Literally, your
PIY
code.
file says pin 16 for the data.
That's GP16 or IO16. Okay.
Okay, so that's down here.
Yep.
All right, so once again, the Zoom window's getting in my way. Do you guys see the Zoom
There we go.
window in my screen too?
Nope, I just see you.
No.
All right.
Chewy box, fridge with beverages, a burnt umber / orange sofa.
I used I'm gonna look at KiCad before I say another number.
All right, so I want to change my drawing to fit that code. So I'm going to go back to schematic. Okay,
Hmm.
and change it there, and then re-import it.
So
And that's as simple as, since we use the labels, right? That's as simple as going into select, selecting this, and moving it. And since I anchored on the right with the wire, I probably want to just move the wire too. But I could just anchor with the left. There's lots of a million ways to skin this cat, right? All right, so now I have NeoPixel, which is the data inline, connected to 16 there. And power is power. That's clearly going to be the same. Ground, you have a specific connection with your ground on your breadboard, but since we talked about last week, we do the ground pour. We're not making a direct connection to a particular ground. We lit up all the grounds, and they're all connected to the ground fill or pour. Then we don't need to set it to a specific. So what other devices did we have connected? We had 2 buttons connected, right?
Mhm.
What does anybody remember what? We never resolved that, did we? We resolved it in chat afterwards, but not during the.
mhm.
All right, I'm going to hold off on that. So then there's the OLED. Does everyone have the symbols for the SSD 1306?
No.
Not sure.
Okay. So let's go through that process because we want to be comfortable going to find new symbols, right? Let me see if I have it.
So one thing you might want to mention is you have to update the symbols to go from GB19 to 16. I know you did it quickly, but
What are you talking about?
when you just rerouted from GP19 to
All I
GP,
did was move the net label
right.
from 19 to 16, and everything else will take care of itself once we refresh in the PCB.
Actually, it won't.
Yeah.
Why?
So if you go to the PCB and first thing I would do is remove the copper pour. So that's Control B.
Well, we're not there yet. I wanted to
Yeah.
I wanted to add the 1306 in, and it will refresh when I switch to PCB and then update changes from the schematic into the PCB.
Yeah, and what you'll find is when you do a refresh of your PCB, you'll have you'll have an error basically that you've got a net going to the wrong pin, but you'll be able to correct it later. It'll get flagged
From a trace that I've already drawn.
Yeah,
I already disconnected that, so yeah, it'll be a rat's nest, but
okay.
yeah, that's the whole point. We'll go through that process. Right now, I just want to add the 1306 in. I want to see if I have it first. I don't know if I have it or not.
So again, button you clicked on you clicked on the choose symbol button.
Yeah, I went to, what is my mouse doing? I went to place, add symbol, or
A.
and then we're looking for display. Is it display graphic? Yeah. Yeah, we'll just search for it, right? I don't know if I have it in this machine or not. I don't. Let's go find it.
All right.
New browser. SSD 1306 KiCad. And they're 128 by 64. That's what we have, right?
Mhm. Yep.
So we can try this one. It's the 4-pin. You will want to look when you get this and confirm that the 4 pins they have in here are the same in the same order as yours. Because I had it once where I've ordered 2 separate batches styles of 1306, and the pins were reversed. And that's fine on a breadboard. It's not so fine when you're ordering boards. Know for sure what you have before you order boards. Save link as. Save it in downloads. Move my junk around. Oh, I don't want to save that. What's in there? I don't even know if this is right. These might be for KiCad 5. We'll see what happens. So we'll go back to schematic. We're going to go to the symbol libraries. Add library, global.
Okay, so go to the window, click preferences, click manage symbol libraries.
Uh-huh.
Yeah. And then make sure the tab is on global libraries.
Uh-huh.
And then you'll click the folder. That should open up the correct prompt this time.
Okay, so that is. Oh, I'm
It
going to have to
wasn't looking
investigate
for
that.
a .lib. It was just looking for KiCad sim. That's why it wasn't
So
showing
this
up.
is a legacy library then.
Yeah.
Yeah.
It was developed 3 years ago.
Yeah, it was before 6 came out. I hope it works. I don't even know if does it work?
Mhm.
It's on my symbol table just fine.
Okay.
Mhm.
Okay. Place add symbol. Search for 1306. Oh, thank God. Okay. Throw it on here. Okay. Now we can go to the now that we have it in symbols. Everybody caught up? Kevin, do you have it?
Yep.
Okay. Betsy, you have it?
I do.
Okay. So hit the select button, double click on it. Am I wrong? Oh, maybe I double clicked on the wrong thing.
Symbol properties.
Edit footprint. Right click on it and edit footprint.
Ah.
And we don't have the footprint, right? So we need to go over and get the footprint. So cancel out of that. Back to PCB editor. Oh, no, I don't want to draw any traces. Okay. Haphazard. This is what it was for hours in the middle of the night with the Tree of Life badge. What the fuck am I doing? What am I doing?
Did you import the footprint?
I'm doing that now. That is what I'm doing now.
Okay.
You don't do them at the same time, right? They're 2 distinct processes.
Right.
So after I did schematic, I came over to PCB, and I'm going through the same process. Preference, manage footprint libraries, global, folder.
This time you're selecting a folder. So just keep going until it says .pretty.
Yep.
There we go.
All right. And that should be, are you teaching this class?
Oh, just the user interface.
Yeah. All right. So that's in there now. So we'll go back to schematic. Right click on here, right click on the 1306, edit footprint, and associate it. What is Jesus? Okay. So now that's associated. Let's wire it. So let's turn it sideways so it makes more sense. For VCC and ground, we can reuse what we've already done because it's the same thing, right? Control C, Control V, rotate twice to get the anchor on the right, and click, right? So ground is connected. Let's Control C on this, 3v3. Control V up here, rotate twice to get the anchor on the right, connected to VCC. Does anybody know what pins SCL and SDA are connected to?
I was not able to get the OLED working.
At all?
It basically, I think it somehow crashed the chip somewhat. Whatever it was getting burning hot whenever I tried to use the OLED.
Really?
Yeah,
Something's not right. That's a wiring problem for sure.
it does sound like that. It
Did you
probably
look
was.
closely at the pin labels to make sure you were connecting the right thing to the right thing?
I
mean, I guess we're not dealing with the breadboards now, but
Mm.
I don't have my code because I was storing my code on my Pico, which is downstairs. So I don't think that I can effectively help with that.
We can talk about that later.
Well, I want to wire it up, right?
Oh,
So Kevin, you want to pull up the Tree of Life code and tell me what,
Yep.
For a valid
Yep, give me 1 minute.
SPI connection for this thing or whatever it is.
Mhm.
do we need just a GPIO pin?
No.
No, this
Well,
has
yeah,
to be-
they are two separate GPIO pins, but I don't want to get too deep into this. But there are specific sets of pins that can be used to control these kinds of devices, right? There's two. I don't have the code in front of me.
Okay, so we have on the Tree of Life, the SDA is pin 12
Okay.
and the SCL is pin 13.
Okay. So let's make a new net label. We'll talk about this more in a minute. Where's my net label? Net label. We'll call it SDA. You say SDA is pin 12?
SDA is pin 12, yes.
Okay. And we'll make a new net label, SCL.
Mhm.
And pin what?
13. The clock is 13.
So yeah, I made that mistake. I looked at the pin number and not the GPIO number. So now I'm moving SDA to GPIO 12. Braden's point is well received. SCL 13. Okay. And then we copy those same labels, Control C and Control V, to the actual pins. And another thing that net labels are great for, if you wire something direct on your schematic, it'll work. But it won't give you intuitive data in the PCB designer when you're looking at, it'll say pad X and pad X, and when you have net labels, it tells you what is connected to what, and it's much clearer.
Yeah, that's nice.
So, oops, back to the select button or escape out. I don't usually escape out.
So SCL is 12 and SDA is 13?
Mhm.
That is not what you told me, Kevin.
SDA is pin 12 and SCL is pin 13.
Yes.
I got that backwards.
Yes. Okay. So let me know when you're caught up. And we can pick anything for buttons, right?
Yeah.
So I'm gonna go ahead and place symbols for buttons. All right, we'll skip the button for now. If everyone's caught up, we'll go back over to PCB.
Mm-hmm.
and we'll update from schematic. It's going to ask you to annotate the new things that you added because they don't have annotations yet. It tells you that it's doing some adding nets and reconnecting, and there's an unconnected net. What's that? We'll find that out. Update PCB, close. So, hey, look, there's my display.
Yeah.
Now, it's hard to read them, but because we gave those net labels, well, no, that's probably on the footprint itself. But now we know what to connect things to, right?
Mhm.
Let's do some fun routing with this. For my stupid design for now, which we might get more into later. I'm going to route this on the back because they're both they're through a hole, right? A through hole. With a surface mount, you're limited to where you can connect that trace to, right? Because the LEDs are on the front, you need to connect the trace on the front. You can go on the back, to get here and there, but you have to connect it on the front because that's where the pads are. With the through hole, you can bring that trace around the whole thing on the back if you want to. And since the Pico is through hole and the OLED is through hole, we can do that. So let's go to back copper and we'll draw this one first. And we'll come out through this gap because I don't want to try to drag it between the pins on the other side, right? And because this is on the back, it like, you can go across this field here. It's not interfering with anything, right?
And to do that is, what was the key tool again to jump to the back?
I went over to the right to go back copper. You're choosing the layer that you want to work with, right?
Okay.
If you're switching back and forth with a via, I guess that's V.
Okay.
But we're not switching. I mean, we could, but it doesn't bias anything here,
Right.
right? And I never finished connecting my GP16. You see that rat's nest between the LEDs and GP16?
Yeah.
All right, so I'm just drawing another trace. And I'm clicking periodically to get it to sort of tame it. Oh, look, I would have to cross. Well, I don't need to cross. I'll come up and over. No, I can't. I don't want to go up and over. So I will via. I will V. No, it's not V. What is it? What's the
Control-Shift-V.
Control-Shift V? What did that just do?
It gets you a freestanding via.
Well, it didn't.
That dot was the via
What dot?
on your cursor. You canceled out of it, but
Okay. I don't know what I'm doing.
I'm adding complexity here, so never mind.
Control-Shift V.
There's that little dot, and then
Yeah,
if you
but
click, you
it
places one.
killed my wire, and that's not what I'm used to seeing.
Okay.
So that's not what I want. No, it's not what I want at all. I do not want a freestanding via. I want a via within the path that I'm in, which is something different. What I'm used to doing, and I learned it last week, and then I promptly forgot it. Right. What I'm used to doing is, let me zoom in so I can see better. Is I right click where I want the via, and say place through via. So it's just V. Is it Shift V? Is that why? Okay. And then I click, right? And I'm zooming out. And now I cross under or over because I'm in front of now. And I could either do I could either go back to the backside or I could stay on the front. It just doesn't matter at this point. It might matter when things get more complex, but for now, I have cured that rat's nest. And this is 3v3, which we don't have to. Yeah, we can do that.
So I have a quick question.
Sure.
So you just spot punch that, you pressed V, you said, when you had that
I did not. I right clicked, but
right
let's
clicked, okay.
let's do another one. Let's
You-
let's
You
do
can,
3v3.
When you're
Mhm.
dragging a wire, you can hit V and that will add a V, I think.
Shift V, right?
Or
Yeah, Shift
will work.
V.
Okay.
Click. And I don't need to Shift V to get back to the front because I'm going to a hole. Right?
So I
So
see
now
an
I have. Go ahead.
well, I see an SDA. So then I'm on the back copper, I guess. So I guess at that point I can just go ahead and go to where I want to go. Okay.
So when you put a component with through hole in the footprint,
hmm
it is definitely connectable on both sides of the through hole.
Okay. So Shift V gave me a little SDA button, like a little graph, and it changed color. Like
Okay.
yours, if you zoom in on yours, I bet you see the SDA in there as well. Or
What on the yeah, to let you, to remind you of what
Yep.
net label you're connected to, and that, like I said, that's the net labels doing that. So
Okay.
that helps tremendously in a crowded board. What the fuck trace am I working on again? You know.
Right.
So again, we won't need to connect the ground because the ground pores should take care of it, and if not, we'll figure out ways around it. We'll connect this because I missed that. There's a lot of little gotchas. So I say I wanted to change the shape of my board, right?
Mhm.
If you change the shape wrong, and this is what I realized at the end of last week that we should have gotten into. If you move some of these lines around, these edge cuts, and you don't have it exactly connected, and it looks like it is, it's going to show. Let's do this.
Looks like we lost Braden. Or where?
I'm sure this is quite boring to him. Oh, I can't. Okay, so it's all connected because I made a perfect square rectangle.
Uh-huh.
It's but when you're doing complex things with like individual lines, it's easy to get them so that they're not connected,
Mhm.
but they look like they are.
That
So
makes sense.
let's do that real quick. Let's go to edge cuts. We're going to talk about layers too. Okay, and then that looks like it's connected, but when you zoom in, it's not. And what's going to happen when you run the DRC on this? You're going to get an unconnected message. Design rules checker up here.
Mhm.
When you run that, run DRC, right?
Where is that in the DRC command?
It's up at the top,
Mhm.
the checklist,
Okay.
right? So when you run that, it tells you all the problems that are problems, right?
Oh, okay.
And some of those are problems, and some of those are not. But what I was talking about is like here, right? And if you double click on it, it'll tell you exactly.
Oh, wow.
It puts a little arrow saying where this is where your problem is, and it does that for the things on the board as well. Let's get rid of this since we got enough real problems. We don't need to make up new ones. All right, is that all of it? I think that's all of it. Oh, nope. Kill. All right, run DRC again. It holds on to the errors from the last time you ran it, right? Still got 18 errors. What are my errors? Let's find out. Clearance violation on the power clearance for NeoPixel. Net class, the power net class between Neo and ground. Okay, let's look at that. Let's just look at some of these and see if we can figure out why. So this is a clearance violation. I don't know why. Oh, because I know why. Duh. Braden mentioned it. The ground. I didn't remove the ground fill.
How do you do that?
You right click, control B, right click on the ground pour and unfill all zones, right? And then right click and fill all zones. So control B and then B if you want to do it quickly. So that should have removed most of the errors that it showed up on DRC because I wasn't even thinking about the ground pour. So run it again. And there are no errors.
Nice.
So it can be challenging when you have errors and you don't know why, but you look for those errors and you dig down deep and there's usually a reason. Sometimes if you try to run a trace between two pins, it'll fit. Maybe if it's not an oversized power line, but you can run traces between here. And if you get a little too close to this or a little too close to another trace, it might let you know that that's a clearance violation. When you get complicated boards like the ones we did, you'll get things like silkscreen clearance violation, like the silkscreen's too close to a trace or too close to a pad. Because do we care? Do we care that a silkscreen is too close to a pad? Probably not. Not for what we're doing. Maybe if you're being professional and all that. Do we need to talk about layers, or does everybody have a real good understanding about layers?
I think so.
I know the front and copper, the front and back, but like where's the drawing layer? You call that.
Let's go from the bottom of the board up, and I'm only going to deal with the layers that matter. Okay. So the very inside, the very core of PCB is FR4, fire retardant version 4, and it's fiberglass, epoxied fiberglass, and that's the substrate, right? That's that ugly yellow stuff that you see when we take off the mask and the copper and the silkscreen and let the light shine through it, right? So then there's copper. So picture a board and then a layer of copper over it, right? And you say pour and fill for this ground here, but that's not really what's happening. What's really happening is they're etching out the parts that aren't. Okay, the whole thing starts as a layer of copper, and they etch out everything that's not, right? For this trace, they etch out the two channels around this. The trace is already there. They're just etching out the channels around it and leaving what's left behind is your trace. Got it? All here too. This is all removed copper. And then above that is solder mask. And that's in our badges, that's the black layer. Right? So fiberglass, copper, solder mask, and then silkscreen on top of that.
Okay.
So it used to be back in the, some of us are old enough to remember when all circuit boards are green. So now we can get them in any color, and all silkscreen was white back then, and now you can get that in different colors, and it's a great time to be alive, people.
So there's the front silkscreen, which will be obviously the front and the back. You can draw on both for art.
Yeah.
Okay.
Picture all those layers I just said are on both sides. Okay. Multi-layer boards we're not going to get into, but picture no solder mask, no silkscreen in between the boards, just copper. So from the outside in, right? Air, silkscreen, solder mask, copper, fiberglass, copper, fiberglass, etc. And you can have 4-layer boards if you have the design skills and the money to do that. And the advantage of things like that is for routing. If you're doing really complicated stuff like the ball grid chips, you really need a lot of paths out, and there's just not enough room to do all the traces on one board. So you run some of them down below.
What's confusing is there's a user drawing appearance. That just confuses me.
There are layers that don't affect the board.
Okay.
The fab layer is for the fab house. User drawing is for the designer that might want to take some notes on it, right?
Oh, okay.
You know, there's lots of, and you can add more layers. A recent development is you can add multiple silkscreen layers for different colors. And it's not automated through the fab houses yet, but you know, you really want to get fancy and have fancy colored designs on your board, that's how to do it. You just, bam. How do you add a layer? Well, I know you can. So these are the layers that matter to us: copper, silkscreen, mask, front and back, and edge cuts matter, right?
Mhm.
So that's everything we need. The rest of it is kind of, you know, extraneous and doesn't affect the badge or the thing that you're designing. We haven't done anything on the back side of the badge, other than a few traces, right? Let's. How much time we got?
We're 10 minutes.
What?
10 minutes.
Okay. What do you want to do? You want to do
Maybe
some
draw-
backside stuff?
We're drawing a little bit. Yeah, maybe.
Yeah.
less
Yeah,
silkscreen.
drawing.
Okay, so all your drawing tools are available. So let's go to the front silkscreen layer, right?
Mhm.
And I'm going to draw a circle because I'm that kind of guy. And I'm drawing outside the lines, but that's fine. Because then I'll move it to where I actually want it. And where do I want it? Let's put it there. Because it's big. Okay, so that's on the front side. And then maybe I'll put a title on here. I'm still on front silkscreen.
Now, won't that block the? Oh, never mind.
Yeah, when you make it, it's not stamped yet. It's not on your board yet. It's you make it and then you decide where you want to put it. So I'm going to rotate it and I'm going to put it over here.
So a question now. The
Yep.
circle that you made, you put deliberately over the 1306. Won't that block the screen on the 1306?
The screen is external to your board.
Okay.
This is just the placement footprint for the 1306.
Got it.
It's not part of this, right? It's just, it plugs into these four holes.
So there'll be art underneath it. Got it.
Right,
Mhm.
right. Which
And
I
how'd you
did
get-
in both badges. I hid things under things in both badges, right?
Got it.
Another thing that's fun to do in silkscreen, like, this is ugly. Okay? This is ugly. I don't like it. I don't like this crap on my board. It's helpful for the fab, but the fab's got the fab layer for that. And is that the fab layer? So that's the fab layer, right? Do you see the eyeballs next to the layers? You can make layers visible or invisible so you can see what they do, right?
Yep.
Okay, so I make the fab layer disappear and all that inner stuff disappears. I was worried because that looked ugly, but now that I know that all that is there, all that identifying stuff is there, I am comfortable taking out the silkscreen for these individual diode labels. What is the X? It's not X. What is it? What's the delete button? Oh shit! What am I doing? Anybody know what the delete button is?
It doesn't work.
It's delete. Son of a bitch.
Yeah, I'm clicking it. It's not deleting.
It's not deleting. Am I? Oh, that you know why? Because here I am over here on the front copper layer. Because I accidentally clicked the trace. That's why everything disappeared. So go back to the silkscreen layer.
Okay.
Select it.
Hmm.
Still not deleting.
Not deleting either.
Probably the footprint is locked. Let's double click on it and see. Oh, that's another thing you can do. That's what I do. unclick visible for the reference, the footprint's reference. You can edit the footprint,
Oh.
but you can unclick visible, and then that label goes away.
Oh, nice.
And if you do that before you make 6 of them, then you're copying a footprint with an invisible reference designator. And you don't need that visible reference designator unless you do, right? That's your decision. If
It's
you need
just-
it for a prototype for assembly to know which thing goes where, that's great. If the fab house is doing it, you don't need that. They've got the designators here if they have any questions.
So the Fab House will do the NeoPixels, and we would do the Pico and the SSD 1306.
Yeah, they'll do the surface mount things.
Mhm.
They'll do anything you tell them to do. I don't think they'll do the through-hole stuff, but you can pick and choose among your surface mount components that you want them to install. If you have a specialized component that they don't stock that you want to do yourself, you can do that.
That's nice.
We'll go into that in the fab episode.
Okay.
It's complicated stuff. So you got design. Let's do something on the back, right? Let's go to back silk screen and text. And I don't know what the hell I'm doing. Okay. And look, it shows up backwards. And it's in a light purple, which is the back silk screen color on my machine. Okay.
Does for language, does the fab care like what you put on there?
No.
Not at all.
No.
Huh.
What do you think? Fab houses are Christian censors or something?
I don't know, maybe?
I will try that
Just
next
asking.
year. I will put pornography on the badge for next year. under a component so no one will see it but us, but
I want to see it under the RP2040.
well, they're going to be installing the RP2040, so yeah, unlikely. Unless you scrape it off. If you scrape off your chip, you will no longer have a functioning badge, but you get to see very low-res pornography. Side note, you can make these shapes in Inkscape and bring them into here as footprints. And there's also a thing in here. Where is it? Somewhere in here there's a footprint designer. I don't think it's in here. I think it's off the main menu, right? Off the main menu, like out the project menu, there's a footprint designer where you can bring in an image and turn it into a footprint. And it's, it's primitive, but it's how I got all the shapes in the Tree of Life badge, all the little symbols that are all over the board. They were manually created one by one.
So question for the battery pack, I guess, is that something like, again, it could be like through a hole and put on the back, something like that?
Let's do that. Let's add one.
Oh, okay.
Because we need power for this thing, right?
Mm-hmm.
Good call. Let's go back to schematic
Mm-hmm.
and place, add symbol. And what you want to do, okay, so yeah, the symbol can just be a battery, right?
Mm-hmm.
And we'll throw that in here. And we will tie positive to VBus, correct?
Mm-hmm.
And then we will copy the ground label to negative. And then we'll, so the fun part about this, back to select, oops, I don't want to double click there. Double click on somewhere in the symbol. And this is what I was looking for earlier, is this way to edit the footprint, right? Let's see what kind of footprints are available for batteries. I hope there are battery holders already in here. Yeah, look at that, whole bunch of them. Keystone is a popular one. Do you realize you know you can move these things around, right?
Which keystone did you like?
What I usually do is I start with, like, I know I want 2 AA's, right?
Yeah.
So I choose that, and then I go and make sure that that particular model is available
Right.
through like DigiKey or Mauser or whoever, and it's a
Mhm.
reasonable price. And if it's not, then I'll find one that is a reasonable price, and I'll look in here and see if we have a symbol for it.
Mhm.
And it's a give and take, right? You have to be able to source the parts that you're designing for.
Yep.
So I'm going to assume that this is an available part, the Keystone 2462, and I associated that footprint with this symbol.
Mhm.
Not a valid library identifier format. Well, why not? What did I do? All right, let's try this again. Are you guys doing any of this?
Yeah, I was able to do it.
It worked?
Mhm.
For you?
So 2462, is that right?
That's what I'm trying to associate with. It gave me an error. Okay, that time it didn't. I don't know why. Okay. So now that's associated with that. I don't know what I did. I must have clicked something stupid. Back to PCB. Back to update from schematic. Annotate. So we got some reconnections. A new footprint's been added. It didn't throw any errors, which is good. Always look for errors here, because if something's wrong, it might not import a symbol.
Mhm.
So look how big that
Yeah.
battery holder is. So the first thing we want to do is, well, we can't put it on the front because it's too big,
Mhm.
right? And other stuff's in the way. So while you're moving it around, before you even place it, hit F, the letter F.
Oh.
Now it's on the back.
Nice.
Now you pay attention to where the pins are for this,
Yeah.
and make sure that it's not going to interfere with anything. And like, it doesn't matter where the body of it is on the
Right.
back, because we don't have anything else on the back, but you don't want the pins to be like, somewhere where they're going to interfere, right?
Mhm.
So you put it here because the battery holder has got the 2 long pins that are going to stick through that, and then you solder them and then you trim them, right?
Mhm.
All right. So click, it's there. Now I've got a battery holder, but I haven't got it wired yet. So I'm gonna run a trace. And again, because this is through hole, it can be front or back.
Mhm.
I think I'll do front just for kicks. Do what you want. I'm gonna run this one. Oh, I can't. Yes, I can. Why is it moving around? Oh, I didn't hit wire. Wire. Click here. Is that where it's supposed to connect? It's not noticing me. What am I doing wrong?
No, it worked.
I'm going to go back to my schematic because maybe I didn't connect it all the way. No, it looks like it's connected, doesn't it?
Yeah.
And it had a rat's nest.
And then the ground is going to be covered by the copper pour.
Yes.
Mhm.
Yes. Well, we'll see what's wrong with this in a minute.
Mhm.
Run DRC on it. If you have questions, right? It did not resolve this, and I don't know why.
Yeah, I got yours.
Maybe
too.
because the device is on the back and it doesn't understand, or maybe I didn't have it all the way on here.
Yeah, I'm getting like silk screen clipped by solder mask all over the place.
That's fine. Those can be
Oh.
ignored.
Oh, okay.
Yeah, we don't care about silk screen errors,
Okay.
things like that. All right.
Mhm.
I'm going to try to run this trace on the back and see if that makes a difference. Hit wire. It would help to hit wire. back copper.
Can you just flip it rather than having to, like if you already have a trace, instead of redrawing it, just flip it to the back?
I've never tried flipping a trace that way.
Mm-hmm.
Oh,
I'm gonna try going to the back while.
For some reason, this is not wanting to connect. And I'm not sure what I'm doing wrong.
I did not have an issue.
Does it work for you?
Yeah.
What am I doing? Go front. Let's start from here. Like it's not even seeing this as a trace. What did I do? All right, I'm not sure what I'm doing around here.
What is silkscreen clipping? What does that mean? Just curious.
Well, when solder mask is removed,
Mhm.
right? Which that's what it is when you're defining a mask area. It's removed. The silkscreen has no place to sit. The silkscreen is drawn on the solder mask. With no solder mask, there's only copper and fiberglass, and the silkscreen is not going to stick. And they're just warning you that whatever you're printing here is not going to be visible.
Oh,
Does that make sense?
yeah. Like, well, our little, oh, so we won't see what we just drawn.
Where?
Like with the circle or the.
You just won't see this little section next to the trace.
Oh, okay.
Well, no. Let's look at everything but the mask, right? Turn off copper. Leave silkscreen on. Turn off back copper.
I think I ran out of room with all of these wires that I'm drawing.
Are you drawing a
Because-
lot of wires?
Yeah, I am. I don't think I can connect VBus without having to expand my PCB, so I'm gonna go do that. Gonna make a huge wire going all the way around.
Hole clearance violation. Oh, so when you click on if you have an error in DRC
Mhm.
and you click on the line of it, it'll highlight where the error is. So this is okay. Now I see where this problem is. For me, when I place that battery holder,
Mhm.
the battery holder includes two holes in it. I'm not exactly sure why.
Oh, yeah.
So that interferes with that trace that I've already drawn. So I just need to hit M and just nudge it out of the way so that the holes and the pads are not touching any traces,
Okay.
right?
Fair enough. Yeah.
And that should clear up some of my DRC.
Do you have to redo the update PCB changes or no?
No, because I didn't
Okay.
change anything in schematic. This is all physical board stuff.
Interesting.
So here's another clearance violation. Let's see if we can. Through hole pad of BT1 and the ground zone. Okay, so now I need to undo the pour again. Control B. Oops. Close. Control B to undo the ground pour. And let's fix these DRC errors. No, let's do the ground pour again. Okay. Right? Run DRC again. I got 15 warnings and one error. Let's find the error. I don't see the error. All right. Line on silkscreen. Silkscreen's clipped by solder mask. Oh, here's a cool thing you can do. If you click on somewhere, there's a exclusions. Okay. Somewhere there's a way you can say, I don't want to hear about this particular type of error. Right click. There we go. Ignore all silkscreen clipped by solder mask violations. If you right click on the error.
Mhm.
So now there's a silkscreen overlap between the circle and a line.
Yeah.
And that's here. And I don't care. Silkscreen overlap, ignore all silkscreen overlap violations. Don't care. So DRC is clear. I'm not sure how, because my power is not connected. That makes me wonder if I did something wrong on the schematic side. So it correctly got my ground connection for the battery, right?
Mhm.
You see that the red cross there?
Yep.
That's the connections from the ground port to ground. And I want to respect everybody's time. If anybody has to go, feel free to go. We'll just keep talking, you know.
Yeah, I gotta go. I'll catch you all next week.
Okay.
See you, Bets.
Laters.
Yeah, Betsy.
I still don't understand why.
It's kind of good though. It's a good exercise for practice, to be honest with you.
No,
like
I think
going through it.
I think I understand what's going on here. I think I connected the wrong thing to this because it doesn't have a label, and it should have a label. So I'm going to go back to schematic and see what I did. Oh, it doesn't have a label because I didn't give it a label. Okay, let's give it a label because that would make it clearer. I'm going to get rid of this trace because traces are ugly, right? And I'm going to make a new net label, and I'm going to call it VBus. And I'm going to connect it to VBus. And I'm going to Control C and Control V and connect that to here. Right?
And where does that go to the pad?
Say again?
The V bus actually, hold on one second. That actually goes to the top of the battery terminal.
To the
Is it-
plus, to the positive
Yeah.
side.
Yeah.
So it does go to the positive side. That was a question I was gonna ask.
Yeah.
Not the negative side?
No, because you're providing power from the battery into VBus to power the Pico, which then spits out power to everything else through the 3v3 out.
I guess what I'm saying is the positive side provides power. I thought it was the negative side.
We're not getting into electricity right now.
Okay. I'll take your word for it.
We've done this, right?
hmm
I mean, we could look at previous schematics, but I'm 73% sure.
Okay.
So since I made that connection, I want to update PCB from schematic. Okay, reconnected to VBus. And I want to undo my ground pour, and let's see if I can get this going this time. It's still not lighting up that Pico, and I don't know what I did wrong. I must have broken something on the Pico connection.
So I'm not able to connect to V bus for whatever
Yeah,
reason.
I'm not either. I don't. What did we do?
I don't know.
Because I've done this a whole bunch of times. What? I mean, it doesn't. What did we do wrong? It's
Hmm.
recognizing that the ground needs to be connected, which is great.
Where are you
Oh,
connecting?
wait.
Oh.
I want to go to copper. That's what I want to do. It's not recognizing that. Let's go from the backside. What if we go? You can't really run traces from any of these now.
I think I'm going to head off for the night.
Okay.
Got a ton of studying before this interview, so
Good luck.
Were you able to get these to connect?
actually, yes, I was. I had to expand my PCB because it ran out of room. But yes,
Okay.
Yeah, I'm running into all sorts of problems, but it's good. I mean, this is a good thing for me because it's forcing me to figure things out
Yeah, I
in practice.
clearly I broke something. I don't know what, but clearly I broke something. I'll mess around with this later and fix it before next week.
Yeah, we're good. I mean, this was good for me because it was more practice and like I understood the battery that I put on the SSD. It was good.
yeah. Same here. This was a good good tutorial in practice.
We didn't get everything I wanted to talk about done, but
We'll be all right.
we still got another week before we have to go to Fab. So
Boy, it's like the
Is
it's like
the
the real
goal
thing.
is the
Like-
goal to get something before Christmas?
I mean, if you actually want to get something created, yeah, that I think one more week of filling the gaps, right?
Mhm.
And then 2 weeks from tonight would be the final in the class, and we'll go through the whole Fab process and submit something.
Okay.
That's cool. Yeah, I want
So
to.
maybe mess around with your homework. I don't want to call it homework, but figure out what you want for a design. I wanted to make something for my church, but I don't want to do it with the Pico because I don't want to
What-
spend a
the
whole lot of
V-Bu-
money on it.
I think I have an idea. The V-Bus wire is thinner than the other plus wires. It's a thinner wire. Didn't we have to select? Or maybe not. But like my wire is thinner. Then a 3.3 volt wire is thicker. Does that
Yeah,
make
but
sense?
that should be handled behind the scenes.
It's not though.
Anyways, see you guys on Monday, or if
Yeah.
not, next week.
Yep.
Bye.
See you later.
All right.
Yeah, for whatever reason. I'll mess around. This will be good practice. But yeah, like when I click the plus sign where the battery terminal is, the
Uh-huh.
wire is not as thick as the other 3.3s. That's strange to me.
Okay, so that would be under preferences. Board setup, right? I think it's board setup.
So, okay, what did you want? Preferences?
File board setup.
Mm-hmm.
Waiting for it to load. Net classes, right? And go to power. And then you add VBus to that,
Oh,
right?
so you click power,
Now you add
add one. Okay.
VBus with those same settings as power,
Oh, okay.
because VBus is a power line, and we want it to be that fatter
Yep.
thing.
Okay, cool. But yeah, everywhere I press it, there's all sorts of problems. Like there's not enough room in the board.
Oh, and look, now it's connecting.
So, okay. So
Is
now,
that all that VBus didn't have a class defined? Look at that.
Okay, connected.
So yours connected also?
Yeah, but it's still a thin wire. I don't know why.
It does look like it's thinner than the.
Yeah, that's weird.
I wonder if there's something that has to be. Well, I'm not super concerned. It's not going to affect us, but maybe we can ask Braden about that later.
Yeah, it's fine.
And then B, to redo the ground pour. And here's what what I wanted to get into in the class. You still got it up?
Yeah. Mm-hmm.
Go to View.
Yep.
3D Viewer.
Oh, wow.
Oops. It went away. You can move it around.
Hell yeah. Oh, that's why it's covering the. I see what my problems are. It's covering the Pico holes.
What is?
The battery pack. I have it over the Pico holes.
That's
I
fine
got
if
it.
you're not gonna. That's fine. You know why that's fine?
Why?
Because you use the castellated pins on the Pico. You don't have to have through hole.
Oh, but you'd have to. Ooh, no. I don't. I want to solder through hole though.
Okay. Okay.
Yeah, I don't want to.
You don't want to do castellated?
No.
So yeah, you might want to make your board big enough to put the
Yeah.
battery
Yeah.
holder vertical on this side.
That's really awesome. That's
Yeah.
I want to figure out the V bus. You said was board.
Board what? File
setup.
board setup.
Yeah, I'm there.
And then let me close the 3D viewer.
V bus. Yeah, for V bus.
I clearly need a new computer. So yeah, I made the track with for VBus the same size as the other one.
0.35, yep.
Yep, and all the other things are the same.
And then you select VBus, right? You have it set on 3.3.
Well,
net. Mhm.
I don't know what that is.
Oh, and then select VBus for the default. That's what I was missing.
Where?
In the net class,
Yes. Yeah. I typed that in.
right? And then on the right, on the right-hand side where there's net class, you see VBus, then you have to select it there too.
Oh. Oh, then I didn't need to add one. I could just call it a power class. All right.
Oh,
I'm going to get rid of my VBus line.
well, I
It's
like
just
it. It's just
class it as a
easier.
power. This makes more sense. Yeah.
Mm.
This is my first time using this net class definitions this way. So now it should have made them bigger, did it? Maybe that's the redraw. Anywho,
No, it's cool. It's good.
it's working. I'm going to save it. And we'll come back next week. Maybe I'll do some intermediary thing and talk about the buttons and how to wire it up so we're all on the same page for next week.
Yeah, it works. I think it was good. It works.
What are we doing Monday?
Aren't you off or something?
Oh, that's right. That's right. My daughter's home until
Yeah.
Tuesday. So, yeah, I will not be present in any meetings,
That's fine.
which is great. I might have some time to clean up the basement.
Woohoo! Enjoy.
All right.
Happy Halloween.
Yeah. Thanks for coming.
All right. Thanks, Bob. Take care.
Later.